Hello everyone, welcome back to Calculus 1. And this time we will continue work on section 3.3, differentiation rule. And so far, if you remember, we introduced actually two rules which will give derivatives directly. If you remember the derivative power rule and the derivative exponential rule, and then we have sum rule and the constant multiple rules. And we really don't know how to handle the derivative of a product. Or really, if you are thinking what I'm talking about, let's say if we are having a function like such, this really should be considered as a power function, right? X, well, a product of two functions. A power function x squared times the exponential function. We do know derivative of x squared is 2x. Derivative of the exponential function, remember we know it's the only function such that the derivative itself. So is it okay to say the derivative would be 2x times e to the x? Certainly it's not correct. Okay. To calculate the derivative product, it's a little more complicated. And we will not go through all the details. I just want to present the rule in this part of discussion, the product rule. So there are two formulas, similar there are two formulas, but anyway, they are the same, okay? This is kind of long. I'm not sure if you feel comfortable to read, but anyway, the reason mostly I really want to know, I'm following the textbook. I believe this is how it is presented on the textbook. This notation means the derivative of f of x times g of x, then it would be g of x times derivative of f of x plus f of x times derivative of g of x. Certainly, if you understand the idea very well, it's not that a big deal. But anyway, I say for beginners, looks like, well, the formula is pretty big and might be very intimidating. Okay. So I would suggest you use this fashion because there are two functions involved. Instead of using f of x, g of x, how about let's make things easier. Let's just call u for f of x, then v for g of x. So f of x times g of x simply can be written as u times v. And with the prime notation, derivative of u times v is u prime v plus uv prime. Compare the line over here and the line in the middle. I say it is a lot easier to remember the product rule using u and v. But anyway, make no mistake, the formulas really are the same. This is just easy to write and easy to remember. But anyway, it is really the same as this long-fashioned formula. Long-fashioned formula, okay. And now let's consider the example as I mentioned earlier, how we calculated derivative. Okay, I'm taking u as x squared, then v as e to the x, and then clearly we can calculate the derivative for each. U prime, which is 2x, and v is e to the x, so v prime, just add a line notation here. V prime, it is e to the x. And again, derivative e to the x, it is the only function. It is itself, e to the x. Okay. So using the product rule, we have y prime, it is u prime v plus uv prime. I just copy and paste the same product rule. And then replace each notation with the formula. U prime, as we calculated, that's 2x. V is e to the x. U is x squared. V prime, it is e to the x again. That's y prime, believe it or not. And similarly, I did another calculation, and somewhat I did not show u and v together, but anyway, hopefully it's easier to follow, right? Derivative of x times e to the x. Derivative of x is 1 times v, e to the x. Then x times the derivative of e to the x, it's e to the x itself. So derivative of x times e to the x. Maybe let me put a pair of parentheses. I think it's okay even without a parentheses. This is how we understand the derivative. Okay. And so if I have parentheses, it might be better we also have parentheses here. Take the derivative of x cubed times e to the x. So derivative of x cubed, that's 3x squared times e to the x. And the derivative of e to the x, it's itself. I'm taking u as x cubed, v as e to the x. So it should match precisely u prime v. This part, it is for u prime v plus u v prime. Again, one more time, derivative product rule. Derivative of a product, it is u prime v plus uv prime. Okay. One more. Derivative of square root of x. It might be a little more complicated. Okay, so you want to take a square root u as square root of x, v as e to the x as always. And then for square root of x, actually I repeated my calculation here. Okay, it is in the previous part of the same section. Remember, square root of x, we consider as x to the 1/2. So we bring down this 1/2, then decrease 1/2 by 1 turns to be negative 1/2. And also make it looking a little better. I mean, it's just not that direct to understand x to the negative 1/2. So I converted it back to the radical notation. It is negative. I don't think there's minus sign here. There should be no minus sign. I don't know how to get this minus sign. There should be no minus sign. 1/2 times square root of x. Square root of x in the denominator, which really means x to the 1/2. Then using the same arrangement, the product rule. Okay, I got those as the derivative for the product of square root of x times e to the x. Okay, let's do a little more about the product rule. The next example, I'll let you know, it is really from the textbook, and I did it two ways. Because really precisely the derivative of this function j of x, well, maybe if you want, you may choose not to use the product rule. So I did it two ways. As I'm saying, if you only have a problem like this, you may not want to consider product rule. I say product rule somewhat complicated, right? You're going to add two derivatives together, u prime v plus uv prime. Okay. So for this example, the first arrangement I did here is I just use the FOIL rule to multiply this out. So the first term, x squared times 3x cubed, 3 times x to the 5. The out term, it is x squared times negative 5x. Don't forget the minus sign, minus 5x cubed. And plus the inner term, 6x cubed. The product of two last terms, negative 10x. And usually it is just true. The out term and the inner term can be combined. And still this time it is true. So we have the trinomial like such. Then from the trinomial, not from the product, I calculated the derivative using mostly the power rule and combined with the sum rule, difference rule, and the constant multiple rule. So I got the derivative done, right? And the second method, because I'm presenting the product rule. So anyway, I feel it's necessary to give a try using the product rule. So this time I did not use the FOIL rule. Okay, I just take u as the first factor, v as the second factor. Then I got a u prime, and also I got a v prime. Hopefully they are very straightforward calculation, right? Then I think, am I correct? 3x cubed, so that's 9x squared. I believe I'm all right. Okay. Then we have u, v, and u prime, v prime. Then according to the product rule, it turns out to be u prime v plus u v prime. So carefully plug in all those expressions for the corresponding notations. And then I simplify this. Actually, believe it or not, the answer I got in the end, it is really the same answer as I got from the first method, right? So I did this problem from the textbook. Okay, so example 3.24 in 2 ways. And I hope you are convinced. Okay, the derivative we got without using product rule and the derivative we got with the product rule should be the same. It should be the same because it is really for the same problem. Okay, this part, it is the derivative product rule. This is the product rule formula for the product rule. Hey, thank you for watching.